In this class, we're going to go over question on a replacement model. What do we mean by a replacement model in economics? Replacement model refers to a concept used to analyze the decision-making process of a firm or individuals when it comes to replacing capital goods such as machinery, equipment, or vehicle. You understand? Okay, when we talk about a replacement model, that word, that statement consists of two words. We have one, replacement, and we have model. So a model that shows the time to replace the capital goods of a firm or an individual is called a replacement model. You understand? What does it mean to replace? To replace simply means to change. You understand? So now, when we talk about capital goods are those goods that can be used over and over again. You understand? These goods are used in producing other goods. Are you paying attention? So, for example, let's take for instance, let's say, okay, let's go to farm now. We have tractor. You understand? Tractor is used to move. You understand? It's used to lift. So, using tractor as an example, you can see that tractor doesn't just we don't use it once. You understand? Now, in the process of the usage, it started to depreciate. Are you paying attention? And it got to a point whereby it will need replacement. That is why this model is very important. You understand? I don't know, maybe you understand that example. Maybe, okay, let's say you have a vehicle. Okay, you have a vehicle. Now, in the process of time, the efficiency of the vehicle will begin to depreciate. Are you paying attention? And it will go to a point whereby you will need to replace it. Now, what this model explains is that the time required to replace the capital goods that we have in our firm or as an individual. You understand? That is why this model is very important. Okay, so let's look at some work example in an attempt to help us understand these concepts. Okay, now the purchase price of an equipment is 5,000 naira. The running and maintenance cost is 800 naira per annum. Are you paying attention? For the first 5 years. Thereafter, increasing by 200 naira annually. If the discount is 10%, what is the optimum time to replace the machine? That's the first question. And the second question, what amount of money should be set aside each year for the replacement of machine for a new one? Okay, now let's start by writing out the information that were given in the question. You see, I'm going to simplify this concept so that you are going to understand. All you have to do is that you just have to pay attention. Okay, now you are given that the purchase price of an equipment is 5,000 naira. So we have solution. Now the purchase price is 5,000 naira. We have purchase price is 5,000 naira. Okay, now, and we are given that the running cost, when we talk about the running cost is the maintenance cost. You understand? Maybe some part of the machines or some part of the capital goods or the resources that you are using is not effective enough. Maybe the tire, you understand, the oil, the engines, those are running costs. You understand? The cost it takes to maintain the capital goods. In this case, we are using equipment, so the cost it takes to maintain the equipment, that is what we call running cost. You understand? So that one is 800 naira. You understand? Running cost. The running cost is equals to 800. Okay, 800 naira. Okay, now we are given that okay, per annum. That means that, let me just put it, per annum, 800 naira per annum. Now let's proceed for the first 5 years. For first 5 years, in 5 years. Now, okay, thereafter, the running cost increased by 200 naira annually. If the discount is 10%, okay, so we have discount. Discount is equals to 10%. We are asked to determine the optimum time to replace the machine. You understand? The time the machine should be replaced. You understand? That's the first question. Now, in understanding this concept, I'm going to give you 3 formulas. You understand? You might come across many textbooks or you might come across many materials that tends to give you more than 3 formulas, but I have helped you to simplify this concept. Understanding the 3 formulas that I'm going to give you you are going to you'll be able to solve question on a replacement model, because you might come across this kind of question in your exam. Okay, so now please kindly pay attention. The first formula is the formula of the value of the asset. You understand? I will call that one V, the value of the asset. Hello, pay attention. The value of the asset. V is equals to 1 all over 1 plus R. That is the first formula. Please, it's simple, okay? That's why I take it step by step. It's simple. V is equals to 1 over 1 plus R. The V that you have here means the value of the asset, you understand? And R is the discount rate. Are you paying attention? That is the first formula. Okay, now let's proceed to the second formula. The second formula is equals to Pn is equals to Ci plus RT plus V raised to the power of n minus 1. That is the second formula. Okay, you just have to pay attention. I'm going to explain. Now the third formula is for annuity. Are you paying attention? Annuity is given by this formula. Ai is equals to Pn into bracket. Now I'm going to tell you the parameters that we have in this formula. Okay, Pn into bracket 1 minus V all over 1 minus V raised to the power of n. Okay, these are the three formulas that we need, you understand, in an attempt to solve this question. The first one is for value of the asset, you understand. The value of the asset V is equal to 1 over 1 plus R, and the second one is Pn. Pn is the present value of the total cost. Are you paying attention? The present value of the total cost is Pn. And Ci, this one that you have here, Ci means the initial cost. Are you paying attention? Ci means the initial purchase price, initial cost of the asset. Are you paying attention? And the RT that you have here, RT simply means the annual maintenance cost. Are you paying attention? The annual maintenance cost. And we have talked about V. By the time we get the value of V here, you just have to pay attention, okay? The same V that you see here is still the same thing. Are you paying attention? V signifies the value of the asset, and the n in which V is raised to the power is numbers of years. You understand? N signifies the numbers of years. Now, for the third formula, let's talk about the parameters. The AI that you see here is the annuity. You understand? Annuity, and Pn is the present value of the total cost. Why V is still the same, which is the value, both V, which is the value of the asset. Okay, now having understand all the parameters that we have in this formula, let me give you a condition. The condition for optimum time of replacement, I want to give you that condition now. The condition is where one, please pay attention. Where should I don't want to erase it, so I'm going to put it here. The time to replace the asset, I'll just put it in bracket, okay? The time to replace the asset is when, please pay attention. Oh, this has removed. Yeah, okay. The time to replace the equipment is when 1 minus V raised to the power of n all over 1 minus V. Please, 1 minus V raised to the power of n all over 1 minus V to the product of R T plus 1 is greater than Pn. Hello? Listen to the explanation again. You know, the first question says we should determine the optimum time to replace the equipment or to replace the machine. Now, this condition is important, you understand? Don't worry, we are still going to prepare the table, you understand? I'm just trying to explain the basic concept so that by the time we delve into, when we prepare our table, you are going to understand, okay? See, the condition for optimum time to replace the machine is that where this 1 over V, 1 minus V raised to the power of n all over V, 1 minus V multiplied by RT plus 1 is greater than Pn. That is when to replace the machine, you understand? The year, let me put it. the year, optimum time. This is the condition, optimum time of replacement. Optimum time of replacement is when this is greater than Pn. You understand? That year is the year which the machine needs to be replaced. You understand? Okay? Now, so having understand all these concepts that you have here, now let us prepare our table. Okay? So I've already prepared my table. You understand? What I'm going to have on this table is determined by what I want to calculate. You understand? Are you paying attention? So please, I want you to pay attention. Here, I'm going to have year. You understand? The first column will stand for year because we are now dealing with time. You understand? We are dealing with time, and the first question says we should calculate the optimum time to replace the equipment. You understand? So now we are dealing with year. So I represent year as YR. Okay? So now, because we've been given that the year that we are given is 5 years. You understand? So I'm going to start with 5 years. Don't forget that the goal is to determine the year when this is greater than this. You understand? It might not be 5 years, it might be 10 years, but because we have been given in the question that the first 5 years the running cost is this, so I'm going to start with 5 years. So if maybe when I'm solving the question, then I discover that among those 5 years there is nowhere where this is greater than Pn. That means that I'm still going to proceed to the 6th year, 7th year, until I got to that year where this is greater than this. You understand? Where all this is greater than the present value of the total cost. That is the year where as that year is the optimum time of replacement of that equipment. Do you understand? That is why I gave you the condition at first. Okay? So now I'm going to have year 1, year 2, year 3, year 4, year 5. Okay, let's start with year 5. Let's stop at year 5. We can still have year 6. Okay, but that is if among these years we didn't have any value in which this is greater than this. Are you paying attention? Okay, so we have 5 years. Now on this column I'm still going to have the cost. You understand? So I'm going to represent the purchase price is the cost. You understand? If you go to market and purchase maybe you want to purchase a pen, you understand? You're going to pay for the pen. That pen, the price that you pay is called the cost. You understand? So now we have the purchase price. The purchase price is also the same thing as the cost. So here I'm going to have the cost. So I'm going to represent it on this table as C. Okay? So I'm going to have C in this place. Just pay attention. You're going to understand. Now, because on this formula as well, I need the RT. You understand? Hello? I need the RT. You see, it is this formula that tells me what I'm going to have on this table. Okay? This formula tells me what I'm going to have on this table. So now, when I have the cost, I need the RT. Don't forget that RT is for running cost. You understand? Or maintenance cost. And the running cost is what? Is 800 naira. That is for the first 5 years. You understand? So I'm going to have RT. Okay, so now for the first 5 years, if you look at the question says that the maintenance cost or the running cost is 800 naira per annum for the first 5 years. So the running cost will be 800 naira for the first year, 800 naira for the second year, 800 naira for the third year, 800 naira for the fourth year, 800 naira for the 5th year. You understand? If the question says the running cost is 800 naira for the first 10 years, that means that we are still going to have, are you paying attention? We are still going to have 800 naira is going to be to the 10th year. Are you paying attention? So now, and the purchase cost, the purchase price for the first year will be 500 naira. 5,000, sorry. 5,000, because we are given that the purchase price is what? 5,000 naira. So the purchase price will be 5,000 naira. That is for the first year. You understand? The year in which the equipment is being bought. Okay. So now on this table as well, I'm still going to have v raised to the power of n. You understand? If you look at this formula, Okay, look. Just pay attention to this formula. CI simply means the initial cost. I'm going to explain. RT simply means the running cost or the maintenance cost. I need V raised to the power of n. See, This is v raised to the power of n minus 1. I cannot determine the value of v raised to the power of n minus 1. I need v raised to the power of n as well. Look, you can see I have v raised to the power of n here. So it is this, understanding this formula alone, half of the problem is already solved. Okay, if you understand, if you can remember this formula in your exam, half of the problem is already solved, because by looking at this formula, you are going to remember what you are going to have on this table. Okay, because the goals of this table, the reason why we construct this table is to help us to determine what we are going to the values that we have here. You understand? So now the next column will be for v raised to the power of n, because from the formula I have v raised to the power of n. So I'm going to have v raised to the power of n. Now the next column, I'm going to have 1 minus v. 1 minus v. If you look at this, we have 1 minus v, 1 minus v. You see? So 1 minus v. So I have v raised to the power of n. I've already put it there. I have 1 minus v. I've already put it there. So let's proceed. The next column, we're going to have 1 minus v raised to the power of n. How do I know? Because I have 1 minus v raised to the power of n here. So I'm going to have 1 minus v raised to the power of n. Okay? Now, for the next column, we are going to have v raised to the power of n minus 1. Okay? This is v raised to the power of n minus 1. You see? Don't worry yourself. Don't worry about the arrangement of what you have on the column. Just make sure that the goal is to have all these things that you have here, to have it on the on your table. You understand? Okay, so you can see I have c, I have rt. Now I'm going to have v raised to the power of n minus 1, v raised to the power of n minus 1. Okay, so for the present value of the total cost, I've already complete what I have. I have c, I have rt, I have v raised to the power of n minus 1. You can see. So moving to the annuity, I have 1 minus v, it is here. I have 1 minus v raised to the power of n, it is here as well. Okay, now let us proceed. The next column will be the value of Pn. You understand? So this column will be for the value of Pn. Don't forget that Pn is the present value of the total cost. So you can see now, you can see that by knowing this and this, I can easily get the Pn of each year. You understand? Okay, are you paying attention? Now, looking at this formula, what else do we need on this table? Okay, we need 1 minus v raised to the power of n all over 1 minus v. You understand? So here I'm going to have 1 minus v raised to the power of n all over 1 minus v. So that will stand for I've moved from here to here now. You understand? Okay, so we have 1 minus v raised to the power of n all over 1 minus v. You understand? So that will be the next column. Now, the last column will now be 1 minus v raised to the power of n all over 1 minus v multiplied by rt plus 1. 1 minus v raised to the power of n all over 1 minus v multiplied by rt plus 1. You understand? According to what we have here. Okay? So you can see that when you remember the formula, half of the problem is already solved. Is that not it? Yes, it is. Okay? Now, we have gotten to where I want to pay attention at most. Don't forget that v is equals to 1 all over 1 plus r. So let's first determine the value of v. Okay? V is equals to 1 all over 1 plus r. R is the discount rate. You understand? Discount rate is equals to 10%. So I'm going to have, and 10% is what? 10% simply means 10 all over 100. So I'm going to have 0.01. You understand? 10% simply means 10 all over 100. So I'm going to have 0.1 as 10 over 100. So here I'm going to have 1 plus 0.1. So V is equals to 1 divided by 1.1. That will be 0.9091. 0.9091. So here I'm going to have 0.9091. Okay. So the value of V is 0.9091. So having determined the value of V, so I want, please pay attention. What I'm doing right now is that I want to complete this table, you understand? Because the goal is to determine the year where this is greater than this, you understand? So I want to complete the table. V is 0.9091. So the next column, which is V raised to the power of n, is what? For these cells, I'm going to have V is 0.9091. So for the first year now, n is the numbers of the year, don't forget. So for the first year, I'm going to have 0.9091 raised to the power of 1. That means I'm still going to have 0.9091. So here I'm going to have 0.9091. Please, do you understand how I got this? Listen to the explanation again. V is what? 0.9091. N is 1 in the first year, you understand? Hence signify the numbers of year. And the first, we are now dealing with the first year, you understand? So n is 1. 0.9091 raised to the power of 1 is what? Is 1. Okay, so that's how I go. Oh, 0.9091 raised to the power of 1 is 0.9091. You understand? So that is how I got the value. That's how I got 0.9091. Now, let us proceed to the next column. Here we have 1 minus V. Don't forget that V is what? 0.9091. So the next column, I'm going to have 1 minus 0.9091. You understand? So 1 minus 0.9091, that is 0.0909. So here I'm going to have 0.0909. Listen to the explanation again. V is 0.9091. By the time you subtract 0.9091 from 1, because according to what we have on this column, it is 1 minus V, and V is 0.9091. So if you subtract 0.9091 from 1, you're going to have 0.0909. Okay? So for the next cells, we have 1 minus V raised to the power of n. 1 minus V raised to the power of n simply means you are going to subtract V raised to the power of n from 1. You understand? Subtract V raised to the power of n from 1. Now, if you look at V raised to the power of n for the first year, maybe I should rule. Let's rule. Let us rule. This is the first year. We have the first year here. I'm not really good at drawing, so just bear with me. Okay. Okay, so now we are in the first year now. Okay, I'm trying to get all the values for the first year. Now 1 minus V raised to the power of n. 1 minus V raised to the power of n simply means you subtract V raised to the power of n from 1, and V raised to the power of n for the first year is 0.9091. This is it. This is V raised to the power of n for the first year. So if you subtract 1 from 0.9091, you are going to have 0.0909. So I'm going to have here 0.0909. Please, do you understand how I got the value? If you didn't understand, reverse the video and listen to the explanation again. Okay? Now, let's proceed to the next column. We have V raised to the power of n minus 1. Please pay attention. V is 0.9091. V is equals to 0.9091 according to this. Now V raised to the power of n minus 1 will be 0.9091 raised to the power of, now because we are dealing with the first year, we are in the first year now, so we are going to have n will be what? 1. So I'm going to have 1 minus 1. That will be what? 1. You understand? Because when you raise any number, any positive number to the power of 0 according to the laws of indices, that will be what? That will be 1. You understand? So that is why I'm going to have 1 in this place. If you didn't understand, reverse the video and listen to the explanation again, okay? So we have Pn. So to determine the Pn for the first year, you just have to make use of this formula. Look at this. Pn is equals to Ci plus Rt plus V raised to the power of n minus 1. Now, the Pn for the first year, will be equals to Ci. Don't forget that Ci, the cost is what? 5,000 naira. You understand? The cost is 5,000 naira. So I'm going to have 5,000 naira plus RT. Don't forget that RT is what? 800. Okay? 800 plus v raised to the power of n minus 1. V raised to the power of n minus 1 is 1. Have you seen it? See, everything that you are going to have on this column is with respect to the first year. You understand? So I want to determine the Pn of the first year. Okay? And Pn is given by this formula, which is Ci, which is the cost. You understand? The cost should be initial cost, because there is no cost before before the cost of the first year. That is why I have 5,000. You see, all you have to do is just pay attention. Okay? So here I'm going to have 800 plus 1. Oh, I think there is a mistake in this formula. There is a mistake in this formula. This should be multiplication. You understand? This should be multiplication. So here I'm going to have 800 multiplied by 1. Please, don't get confused, okay? You know, when I gave you the formula for the present value for the total cost, the Pn, I mistakenly put an additional sign between the maintenance cost and v raised to the power of n minus 1. That's a mistake, okay? The sign between these two should be multiplication, okay? So that is why I have 800 multiplied by 1. So for the first year, the Pn will be 5,000 naira plus 800, which is equals to 5,800, okay? So here I'm going to have 5,800. Do you understand? If you didn't understand, listen to the explanation again, okay? So now let us proceed to 1 minus v raised to the power of n all over 1 minus v. Now 1 minus v raised to the power of n for the first year is what? 0.09009. Now 1 minus v is what? 0.0909 as well. So I'm going to have 0.0909 divided by 0.0909, that is 1. So here I'm going to have 1. Now, okay, so let's get the value of these cells. The value of this cell is 1 minus v raised to the power of n all over 1 minus v multiplied by rt plus 1. I want you to pay attention. See, 1 minus v raised to the power of n is 0.0909. Don't forget, we are dealing with the first year now. All over 1 minus v. 1 minus v is what? 0.0909. So 0.0909 divided by 0.0909, that is 1. You understand? So that is why 1. That's why we have 1 here. So we're going to multiply this 1 by RT plus 1. RT plus 1 simply means the maintenance cost of the next year. Hello? That's why I say it's very, very important that you pay attention to the explanation. You are going to write, okay? But just first pay attention to the explanation. RT plus 1 simply means the maintenance cost of the next year. Now, because we are dealing with the first year, the maintenance cost that we are going to be using here will be maintenance cost of the second year, because the year that is next to the first year is what? Is the second year. Do you understand? Listen, RT is maintenance cost. The plus 1 signifies that the time that we are, the maintenance cost of the time that we're talking about is the maintenance cost of the next year, not the present year. We are now in year 1 now, but the maintenance cost that we're going to be using to multiply this will be maintenance cost of the second year. Are you paying attention? Because the next year, the year after year 1 is year 2. So we are going to use the maintenance cost of the second year to multiply 1 minus v raised to the power of n all over 1 minus v. Do you understand? And 1 minus v raised to the power of n all over 1 minus v is what? 1. So I'm going to use 1. I'm going to use 1 to multiply the maintenance cost of the second year. The maintenance cost of the second year is what? Is 800. Don't forget that RT signifies maintenance cost. So I'm going to have 1 multiplied by 800. That will be 800. So the value of these cells is 800. Do you understand? Okay, so let us proceed to the second year. That's how we are going to do for all the year. Okay, let us proceed to the second year. Now, for the second year, because we are making reference to the future, you understand? We are not purchasing anything, you understand? So for the second year, we are going to have dash here. We are not purchasing anything. We are just dealing for the we want to know the time it requires to replace the equipment that we have already purchased, you understand? So we don't need we are not purchasing the equipment again. So that is why I have dash here, you understand? We are not purchasing the equipment. We have already purchased the equipment in year 1, okay? And that is why we have 5,000 naira, okay? So don't get confused. That's why we have dash here. Do you understand? Okay. So now let us proceed to v raised to the power of n. V raised to the power of n for the second year will be v, which is 0.9091 raised to the power of 2. Do you understand? Because we are now in year 2, okay? The value of these cells will be v, which is 0.9091. V is 0.9091 raised to the power of 2, because we are now in year 2. So we are going to have 0.9091 raised to the power of 2 will be 0.8265. 0.8265. You understand? So let us proceed to the next cells. I'm going to have 1 minus v. 1 minus v is still 0.0909. So I'm going to have 0.0909. Then for this, we are going to have 1 minus v raised to the power of n. 1 minus v raised to the power of n simply means I'm going to subtract this from 1. You understand? Because v raised to the power of n for the second year is 0.8265. So I'm going to have 1 minus 0.8265. That is 0.1735. 0.1735. Okay? So let's proceed to the next cell, which is v raised to the power of n minus 1. Now, v raised to the power of n minus 1 for the second year, n will be 2, you understand? And v is what? 0.901. So I'm going to have 0.901 raised to the power of 2 minus 1. That will be 0.901 raised to the power of, let me just write it. Here we have v raised to the power of n minus 1 will be v raised to the power of 2 minus 1, which is what? V raised to the power of 1 equals to v raised to the power of 0.9091 raised to the power of 2 minus 1, which is what? 0.9091 raised to the power of 1. You understand? So I'm going to have 0.9091. Okay? Now, let us determine the Pn for year 2. Don't forget that Pn simply means the present value of the total cost. Do you understand? Okay? So Pn for year 2, Pn for the second year will be equals to determine the Pn for the second year, please kindly pay attention. The Pn for the second year will be, please, Pn of the first year plus RT multiplied by v raised to the power of n minus 1. This is the formula that we are going to use to determine the Pn of the second year. You understand? The present value of the second year. Are you paying attention? The present value of the total cost for the second year now will be the present value of the total cost of the first year plus RT multiplied by v raised to the power of n minus 1. Do you understand? Okay, so the Pn of the second year will be, Pn of the first year is 5,800. So I'm going to have 5,800 plus RT. RT is what? Is the running cost. Are you paying attention? RT is the running cost. And the running cost for the second year is what? Is 800. So I'm going to have 800 multiplied by v raised to the power of n minus 1. V raised to the power of n minus 1 for the second year is what? Is 0.9091. So I'm going to have 800 multiplied by 0.9091. Okay? So if you take the product, multiply 800 by 0.9091, that is 727.8. 727.8. So I'm going to have 5,800 plus 727.8. Okay? So if you add this together, 5,800 plus 727.8, that is 6,527.3. 6,527.3. I hope I'm correct. Okay, 6,527.3. That is the Pn for year 2. Okay, so now let's proceed to 6,527.3. Okay, so let's proceed to the value of these cells. Here we have 1 minus v raised to the power of n all over 1 minus v. Please pay attention. 1 minus v raised to the power of n for year 2 is what? Is this. 1 minus v is this. So I'm going to divide 0.1735. Hello, 0.1735 divided by 0.0909. That will give us 1.9087. 1.9087. So I'm going to have 1.9087. Okay? Please, do you understand how I got here? If you didn't understand, listen to the explanation again. Okay? Now, let's proceed to the next cells. we have 1 minus v raised to the power of n all over 1 minus v. See, 1 minus v raised to the power of n all over 1 minus v is this for the second year. Now, we have to take the product of rt plus 1 and this to get the value for these cells. Listen to the explanation again. It's simple. See, 1 minus v raised to the power of n all over 1 minus v is this. It's just, that is the value that we just got, okay? Now, rt plus 1 is the maintenance cost of the next year. Hello? Now, because we are in year 2, the next year will be what? Year 3. The maintenance cost of the year 3 is what we are going to multiply with this that is going to give us the value for this. Do you understand? If you didn't understand, listen to the explanation again. I've already gotten the value of 1 minus v raised to the power of n all over 1 minus v all over 1 minus v. Now, the value for these cells is the product of this and this. And I told you that rt plus 1 simply means the running cost or the maintenance cost of the next year. Now, because we are in year 2, the maintenance cost of the year that we're talking about is the maintenance cost of year 3. You understand? And the maintenance cost of year 3 is what? Is 800. Okay? So here I'm going to have, hello, please. Maybe I should extend this bracket. Let me extend this bracket so I can show the solution. Let's extend the bracket. Okay. Okay. rt plus 1. So here I'm going to have now 1.9. Please just bear with me. 1.9087 multiplied by the maintenance cost of the third year, that is 800. 1 point multiplied by 800. Even it doesn't, the value cannot contain it. Now, if you take the product of this and this, what will be your answer? That is 1526.96. So the value for these cells will be 1526.96. Do you understand? I only show the solution so that you can understand what I'm doing. You understand? Okay, so here I'm going to have 1526.96. Okay, that is the value for that cell. Now let's proceed to the third year. You see, even though you have 800 for all the years, because the question says that the running cost is 800 naira per annum for the first 5 years. That is why we have 800 naira. There are some cases in some questions you might not have the running cost as the same for the year. You understand? That is why I take time to explain what I mean by rt plus 1. rt plus 1 simply means the maintenance cost of the running cost or the maintenance cost of the next year. You understand? Now, because we are dealing with year 2, the maintenance cost that will multiply this value by is the maintenance cost of the third year, which is 800. You understand? Okay, so let's proceed to the third year. Let me quickly tell you this. Do you know what we are looking for? What we are looking for is the year where this is greater than this. You can see. You see, what we have here is this, and Pn is this. You can see that Pn is still greater than this. See, it's simple. I want you to understand this thing. Look, this is Pn. This is the column for Pn, and this the parameter that you have here. This is the column. Now, if you look at this, you can see that Pn is still greater than all the value that we have. So we are not going to stop. You understand? Until what you have here. The year which what you have here is greater than what you have here. That is the year that the time that is the optimum time for the replacement of the equipment. You understand? That is why I gave you this condition. You have to master it. Okay, so you can see that we have not gotten to that year, so we proceed to year 3. Okay, now for year 3 we have v raised to the power of n, because we are now in year 3 and v is what? V is 0.9091. so I'm going to have 0.9091 raised to the power of 3. 0.9091 raised to the power of 3, that is 0.7513. 0.7513. Okay? Now, 1 minus v. 1 minus v is still the same. That is 0.0909. Okay? 1 minus v raised to the power of n, that is 0.2487. 0.2487. Now, v raised to the power of n minus 1, that is v raised to the power of 3 minus 1. And 3 minus 1 is 2. So I'm going to have v raised to the power of 2. V is 0.9091. So v raised to 0.9091 raised to the power of 2. That is 0.8265. 0.8265. The reason, I'm very sure, if you understand the first and second year, you'll be able to do this. Now, PN. The PN for the third year now. Let's determine the PN for the third year. The PN for the third year will now be PN for the third year. For the third year, that will be PN of the second year. PN of the second year, you can see, plus RT multiplied by v raised to the power of n minus 1. So PN of the second year is what? Is 6527. 6527.3 plus RT. RT is what? RT for the second year is what? Is 8. For the third year, don't forget that we are now in the third year, okay? The RT is different from RT plus 1, okay? Now, we are now in the third year. The RT simply means RT of that same year. RT plus 1 simply means RT of the next year, okay? So now, it is RT. RT simply means RT of that same year. Now, we are in year 3. So, RT of year 3 is what? 800. So, I'm going to have 800 multiplied by v raised to the power of n minus 1. V raised to the power of n minus 1 is what? 0.8265. 0.8265. So here I'm going to have 6527.3 plus 800 multiplied by 0.8265. That will give us, please just bear with me, 800 multiplied by 0.8265. That is 661.2. 661.2, okay? Now 6257.3 plus 665.2. That will give us, please, that is 7,188.6, okay? 7,188.6. 7,188.6. Okay, so now let us proceed to the next value. Here I'm going to have 1 minus Vn all over 1 minus V. For the third year, 1 minus Vn is what? 0.2487. So this is 1 minus Vn, 0.2487 divided by 1 minus V, that is 0.0909. So 0.2487 divided by 0.0909. I'm going to have 2.7360. 2.7360. You understand? Okay? So let's determine the value of these cells. For this value, for the value of these cells, I'm going to have 2.7360 multiplied by the maintenance cost of the fourth year. You understand? Because according to this column, it is 1 minus v raised to the power of n all over 1 minus v. And 1 minus v raised to the power of n all over 1 minus v is what? 2.7360. So I'm going to multiply 2.7360 multiplied by RT plus 1. Now, because we are in the third year, and I told you that RT plus 1 simply means the maintenance cost of the next year. Now, we are in the third year. That means that the maintenance cost that I'm going to multiply 2.7360 by is the maintenance cost of the fourth year. Now, go back to the table. The maintenance cost of the fourth year is what? Is 800. So, the value here will be 2.7360 multiplied by 800. Do you understand? Okay, that will be 2,188.8. 2,188 point, let me check, 0.8. Okay, so you can see that we have not gotten there. You understand? We have not gotten there. See, you can see that the value here is still less than the value here. Hello, the value here is still less than the value here. So we proceed to the next year. If let's say that by the time we got to the third year, we discover that the value here is greater than the value here. So that means that the optimum time of replacement will be third year. You understand? But because the value here, which is 2188.8, is less than 7188.6, that means that we have not gotten to that year. You understand? Because we are dealing with time now. Okay? So now we are going to proceed to the fourth year. Now in the fourth year, we have v raised to the power of n as well. Now because n now is 4, you understand? N is the year, n is 4. So I'm going to have v, which is 0.9091 raised to the power of 4. 0.9091 raised to the power of 4 is 0.6830. So here I'm going to have 0.6830. Okay? Now 1 minus v is still the same, 0.0909. Okay? Now 1 minus v raised to the power of n is, that will be 1 minus, now v raised to the power of n is what? V raised to the power of 4. You understand? So I'm going to have 1 minus v, 0.9091 raised to the power of 4. That will be 1 minus 0.6830. That will be 0.3170. 0.3170. Do you understand how I got it? Listen. 1 minus v raised to the power of n is what? 1 minus v, 0.9091 raised to the power of 4. And 0.9091 raised to the power of 4 is what? 0.6830. So that is how I got 0.3170. You understand? That's how I got this value. Okay? Now, let's proceed to this place. V raised to the power of n minus 1. Now, because we are in the fourth year, n will be 4. So I'm going to have v raised to the power of 4 minus 1. V raised to the power of 4 minus 1 is what? V raised to the power of 3. So v raised to the power of 3 is 0.7513. So I'm going to have 0.7513. Now, Pn. Let's determine the Pn for the fourth year. You can see that this replacement model is kind of interesting. Okay, don't let me change the value of v. Let me just erase this. Now the Pn of the fourth year. Pn of the fourth year. Let me erase this as well. You know that v is equals to v. Let me just write it here. V is equals to 0.9091. You understand? So now Pn of the fourth year, the present value of the total cost of the fourth year is equals to Pn of the third year. Pn of the third year. This is third though. Please don't mind my writing, okay? This is third. It is third, okay? Let me erase this. Let me write it clearly. It is third. 3RD plus RT multiplied by v raised to the power of n minus 1. Okay? So Pn of the third year is what? 71888. 71888.6 plus RT. RT of the fourth year, hello, is what? Is 800. So I'm going to have 800 multiplied by v raised to the power of n minus 1. V raised to the power of n minus 1 for the fourth year is what? 0.7513. 0.7513. So here I'm going to have 7188.6 plus 800 multiplied by 0.7513. That will be 601.4. Let me check. 800 multiplied by 0.7513. That is 601.04. Yeah, it's correct. 601.04. So now add this together. 7188.6 plus 601.04. That is 778. 7789.6. So here I'm going to have 7789.6. Okay, so the PN of the fourth year, is 7789.6. Do you understand? Okay, now let us proceed to the next column. That is 1 minus v raised to the power of n all over 1 minus v. Now for the fourth year, 1 minus v raised to the power of n is what? 0.3170. 1 minus v is 0.0909. So I'm going to divide 0.3170 by 0.0909. That is, let's divide. That is 3.4873. 3.4873. So here I'm going to multiply 3.4873 by 800, which is the maintenance cost of the fifth year. So I'm going to have 2789 points. Please kindly pay attention. 2789.84. 2789.84. Okay, so let's proceed to the next year. See, let me tell you, until we got to the year where this value is greater than this value, you are not going to stop. Okay, so I need you to you have to be fast. You have to be fast now. Okay, so for the fifth year, I'm going to have the running cost is still 800. The v raised to the power of n is 0.6210. 0.6210. For this, I'm going to have 0.0909, and this says 1 minus v raised to the power of n is 0.3790. 3790, and for this, I'm going to have 0.6830. 0.6830, and for this, I'm going to have 8,336.6, and for this, we are going to have. Do you understand how I got this? If you didn't understand, all you have to do is that, let me write the equation for you. You know, if you want to get the PN for the fifth year, if you want to get the PN for the fifth year, see, the PN for the fifth year will be equals to PN of the fourth year plus RT fourth year plus RT multiplied by v raised to the power of n minus 1. So PN of the fourth year is what? 7789.6 plus RT multiplied by v raised to the power of n minus 1. That will be, if you multiply this and this, that will be 800 multiplied by v raised to the power of n minus 1. V raised to the power of n minus 1 for the second year, for the fifth year is 0.830. So we're going to have 0.6830. You understand? So by the time you add this together, you're going to have 838,336.6. Okay, now so that's how I got this value. Now for this, we are going to have 4.1694, 4.1694, and for this cells, we are going to have 3,335.52, 3,335.52. Okay, so let us check if this is greater than this in the fifth year. You can see that it is not. It is not at all. This is not greater than this. You can see that the PN is still greater than this. So we proceed to year 6. Okay, we proceed to the 6th year. See, it's simple. Okay, all you have to do is just to master the concept. Okay, you just have to master the concept. It's simple, and that's why I take the time to explain. Okay, so because the value that we have here is still less than this, we are not going to stop. We are going to proceed to the 6th year. Okay, now the maintenance cost, the cost will still be dash. You understand? For the 6th year, the cost will still be dash. let me go this, okay? Okay, so let us proceed. Now, the maintenance cost, oh sorry, because you are not buying anything, the cost, the purchase price is still dash for year 6. Now, the running cost, if you look at the question says that the maintenance cost for the first 5 years, the maintenance cost or the running cost is 800 naira per annum in the 5 years, you understand? For the first 5 years, that is why we have 800 naira. Now, in the 6th year, if you look at that, the next statement after this statement is that the maintenance cost now increased by 200 per annum. That means that if I want to get the maintenance cost for the 6th year, that will be what? 1,000. How do I got it? Because according to the question, we are told that for the first 5 years, the maintenance cost is what? 800 naira per annum. Now, after 5 years, 6 years to downward, upward, you understand? That means that we are going to have it increases by 200. So the maintenance cost for this year will be 800 naira plus 200. So I'm going to have 1,000. I'm very sure you understand. If you learn, you have to learn how to interpret question. Okay. For the first 5 years, it's 800. After 5 years, it increases by 200. So if I want to get the maintenance cost for the 7th year, will be 1,200. Do you understand? Okay. So let's get the values for the VN of year 6, you understand? So don't forget that V is what? V is 0.9091, you understand? So we want to get the value of V raised to the power of N. Okay, now let's get the value of V raised to the power of N for year 6, you understand? Don't forget that V is 0.9091, do you understand? So here I'm going to have 0.9091 raised to the power of 6. 0.9091 raised to the power of 6 is 0.5645. 0.5645. So I'm going to have here 0.5645. You understand? Okay. Now let's proceed to the next column, which is 1 minus V. 1 minus V is 1 minus 0.9091. That will give us 0.0909. You understand? Okay, for 1 minus V raised to the power of N, we are going to have 1 minus 0.5645. So I'm going to have 0.4355. 0.4355. You understand? See, what I'm doing is that what I did for the previous year, that's the exact thing I'm doing. You understand? So, if you want to get the value of V raised to the power of N minus 1, that will be V raised to the power of 6 minus 1, and 6 minus 1 is 5. So I'm going to have V raised to the power of 5, and V raised to the power of 5 is 0.6210. So I'm going to have 0.6210. Okay, for this we need to get the value of the present value of the cost. Now, to get the PN of the 6th year, just listen, okay, you are going to understand. To get the PN of the 6th year, we are still going to use this formula, okay? PN is equals to CI, okay? Let me even change it. Let's change it to PNI. You understand? PN is equals to PNI. The meaning is because the initial value of the present cost, the initial total present value of the total cost of the previous year, you know, that is the that's the PN, you understand? So the PN that we're going to be talking about here is the PN of the previous year, you understand? For instance, let's say we want to get the value of PN for year 6, for the 6th year. We're going to have PN of the 5th year, you understand? You see, I just modify this formula so as to help you to comprehend how to solve the question, you understand? So I simplify the formula such that you won't have to, you won't find it hard when you want to remember the formula in your exams, okay? So here we are going to have PN of the 5th year plus RT multiplied by V raised to the power of N minus 1, okay? So the PN of the 5th year is what? 8,336.6 plus RT multiplied by V raised to the power of N minus 1. Now, RT of the sixth year, RT of the sixth year is what? Is 1000. You understand? So I'm going to have 1000 multiplied by v raised to the power of n minus 1. V raised to the power of n minus 1 for the sixth year is 0.6210. So I'm going to have 0.6210. Okay, this is point. Okay, so for this I'm going to have, that will be 836.6 plus, that is 621. So the value for this, we are going to have 8,957. Okay, so the Pn for this year is 8,957.0. okay, now let's get the value of 1 minus v raised to the power of n all over 1 minus v. See, 1 minus v raised to the power of n for year 6 is 0.4355. So, and 1 minus v for year 6 is 0.0909. So, I'm going to divide this by this. You understand? I'm going to divide 0.4355 by 0.0909. And if you punch your calculator, you're going to have 4.7910. 4.7910. So here we're going to have 4.7910. Okay, let's get the value of these cells. So the value of these cells will be 1 minus v raised to the power of n over 1 minus v. Don't forget, we have already calculated, that is 4.7910. So I'm going to multiply it by the running cost, or the I'm going to multiply it by the running cost of the next year. The next year after the sixth year is what? Is the seventh year. So I'm going to multiply it by the running cost of the seventh year. The running cost of the seventh year is what? Is 1,200. So I'm going to multiply 4.7910 by 1,200. 4.7910 multiplied by 1,200. That is 4,741. 4,741.0. Okay, so I'm very sure you understood how I got all these values. So that is how we are going to get the values for the seventh year as well. For the seventh year, we're going to have v raised to the power of n. For v raised to the power of n, we are going to have 0.9091 raised to the power of 7, and that will give us 0.5132. 0.5132. Okay. For this, I'm going to have 0.0909. For this, we are going to have 0.4868. 0.4868. And for this, we are going to have 0.5645. 0.5645. And here, the Pn will be let me calculate here, 9,634.4. 9,634.4. Then for this is 5.3553. 5.3553. And here that will be 6,426.36. Okay, so let's proceed to the 8th year. See, the reason why we have to proceed to the 8th year is because you can see that this value is still less than this. You understand? So we have not gotten to the optimum time of replacement of the equipment. Are you paying attention? So we are still dealing with the first question. Okay, so it's simple. All you have to do is just to get the steps, and that's why I take time to explain how I got all the values that you have on this table. Do you understand? Okay, so I'm going to have another table. Okay, that will stand for the not really good at the one. That will stand for the 8th and other years. Okay, so I have the table. Here I'm going to have the 8th year, the 9th year, and the 10th year. Let me just put it like that, okay? So we don't know, maybe we are still going to have the 11th year. You understand? So let's just leave it as 10th year now. Now for the cost, we are going to have dash because we are not paying. We are just, all we have to do is just we have to determine the optimum time that the equipment will need the replacement. So we are not paying any amount for the each year now. Are you paying attention? So that's why we have dash here. I've already told you. Now the maintenance cost or the running cost for the 8th year will be 1,200 plus 200, because from the question we are told that the running cost is the same for the first 5 years, which is 800, and then after the first 5 years, the running cost begin to increase by 200. So we have 1,000, 1,200. Here we are going to have 1,400. So here I'm going to have 1,400, and here I'm going to have 1,600. Okay, that is 1,400 plus 200, and here I'm going to have 1,800. Okay, now v raised to the power of n. Now to get the v raised to the power of n for year 8, that is v raised to 0.9091 raised to the power of 8. What is the value? That will give us 0.4665. 0.4665. Okay, now for this I'm going to have 0.0909, because 1 minus v is still the same. If you subtract 0.9091 from 1, we are going to have this. Okay, let's proceed to 1 minus v raised to the power of n. 1 minus v raised to the power of n for year 8 is 0.5335. 0.5335. Okay, now v raised to the power of n minus 1. V is 0.9091, and n minus 1 is what? 8 minus 1. So 0.9091 raised to the power of 7. That will give us 0.5132. 0.5132. Okay, let's get the value of Pn. You just have to use the approach that I use, you understand? So the Pn for year 8, hello, listen, okay? The Pn for year 8 will be the Pn of the 7th year, which is this, plus the maintenance cost of year 8, plus the maintenance cost of year 8 multiplied by v raised to the power of n minus 1 of year 8. You understand? So it's simple. So if you punch your calculator, you're going to arrive at this answer: 10,352.88. 10,352.88. And the value of 1 minus v raised to the power of n all over 1 minus v, that will be this value divided by this. And if you punch your calculator, you're going to have 5.8691. Okay, 5.8691. Okay, now to get the value of this, I'm very sure you understood how we got it. You just have to multiply 1 minus v raised to the power of n over 1 minus v, which is this value, by the maintenance cost of the or the running cost, by the running cost of the next year. The running cost of the next year is the 1,600, because the year after year 8 is what? Is 9th year. So I'm going to multiply this by the running cost of the 9th year. So the running cost of the 9th year is 1,600. So 5.86191 multiplied by 1,600, that is 8,216.74. 8,216.74. Okay, now let's proceed to the 9th year. Now for the 9th year, we already have the running cost. Now v raised to the power of n, v is 0.9091, so I'm going to have 0.9091 raised to the power of 9, and that is 0.4241. 0.4241. Okay, now for this, 1 minus v is still the same, 0.0909, and this 1 minus v raised to the power of n, that is 0.5759. 0.5759. And for this, we are going to have 0.4665. 0.4665. And here the Pn. Please, if you didn't understand how I'm getting the Pn of this year, that means that you didn't understand how I got the Pn of the previous year. Okay, let us proceed. To get the Pn of year 9, that will be the Pn of year 8 plus the maintenance cost or the running cost of year 9 multiplied by, that is 1,600 multiplied by v raised to the power of n minus 1. That is 0.4665. You understand? So it's simple, okay? Now let's proceed. The Pn for year 9 will be 11,099.28. 11,099. Okay, 11,099.28. Okay, so for this 1 minus v raised to the power of n all over 1 minus v. That will be 1 minus v raised to the power of n for year 9 is 0.5759. 0.5759 divided by 0.0979, that is 6.3355. 6.3355. Okay, so let's get the value of this. To get the value of these cells, we're going to multiply this by the running cost or the running cost of year 10. You understand? So here I'm going to have 6.3355 multiplied by 1,800. That will give us 10,136.8. 10,136.8. Okay. Now let's proceed to the 10th year. You can see that it's simple. Okay. Understanding is what matters. Okay. You didn't have to cram, or if you understand the concept, you'll be able to solve it in exam. Okay. So for the 10th year, we are going to have v raised to the power of n. That is 0.9791 raised to the power of 10. That will give us 0.3856. 0.3856. Now let's get 1 minus v. That is also 0.0909. And for this, 1 minus v raised to the power of n, that is 0.6144. And for this, v raised to the power of n minus 1, that is 0.4241. 0.4241. Now Pn. The Pn of year 10 will be the Pn of the 9th year. You understand? The Pn of year 10 will be the Pn of the 9th year plus multiply by, you see, Pn of the 9th year plus, just open the bracket, RT, the running cost of the 10th year. That is 1,800 multiplied by v raised to the power of n minus 1 of the 10th year. That is what? That is 0.4241. If you get the answer, we are going to arrive at 11,862.66. 11,862.66. Okay, now 1 minus v raised to the power of n all over 1 minus v. See, 1 minus v raised to the power of n is 0.6144, and 1 minus v for the 10th year is 0.0979. So I'm going to divide this by this, and if you get the answer right, you're going to arrive at 6.7591. 6.7591. So now, having gotten this, to get the value that we are going to have here, now all you have to do is that you just have to multiply this by the running cost of the next year. Now the year after year 10 is what? Is 11th year. You understand? So the running cost of the 11th year, let me just have let's have the 11th year. Let's have it. We have the 11th year. Okay, so the running cost of the 11th year will be 1,800 plus 200. That is 2,000. Okay, the running cost of the 11th year is 2,000. So I'm going to multiply 6.7591 multiplied by 2,000. 6.7591 multiplied by 2,000. That is 12,166.38. 12,166.3 points. Let me check. 0.38. Okay, so you can see that. Now let us check if the value that we have here in the 10th year is greater than the Pn. You can see 12,166.38 is greater than 11,862.66. That is, the value that you have here is greater than the value that you have here. So it is in the 10th year that the machine or the equipment is going to be replaced. You understand? If you didn't understand, listen to the explanation again. Don't forget that I gave you a condition of the optimum time of replacement of the equipment will be when this value is greater than this value. That year will be the time in which the equipment or the machine is going to be replaced. You understand? Now, because it is at the 10th year, listen, this is how you are going to put your answer. Listen, I want to tell you how you are going to interpret the answer now. Since the value of this is greater than this in the 10th year, that is 12,166.38 is greater than 11,862.66. Hence, the optimum time to replace the machine or the equipment is the 10th year. You understand? So you can see that it's simple. Okay, now let us proceed to the second question. The second question, we are asked to calculate the amount of money that should be set aside each year for the replacement of the machine for a new one. Now, are you done with this? I want to erase that side, okay, so that we can proceed to the second question. Now, let's determine the amount of money that should be set aside. I gave you two formulas. The first formula is this, and the second and the third is this. So, we want to determine the amount that should be set aside. The amount that should be set aside is this. A is equals to Pn into bracket 1 minus V all over 1 minus V raised to the power of n. This formula is what I replace here. Okay? So let's proceed. A amount is equals to Pn. Pn of the 10th year. The Pn of the 10th year is what? 11,862.66. So I'm going to have 11,862.66 multiplied by 1 minus V. 1 minus V of the 10th year is what? Is 0.0909. 0.0909 all over 1 minus V raised to the power of n. That is 0.6144. 0.6144. You understand? So A is equals to 862, sorry. 862.66 multiplied by, okay? Let me just put it in bracket. 0.09 divided by 0.6144. That is 0.1479. 0.1479. So here I'm going to have 0.1479. Okay, take the product. That is 1,754.48. Okay, so A is equals to, just approximate to the nearest whole number, that is 1754. So the amount of money that will be set aside per year to replace the machine for a new one is 1,754. This is naira, okay? 1,754 naira. Let me put the approximate sign very well. So you've seen, oh God. Now, so that is the amount that should be set aside per year. If the company or the firm or the individual that owns the machine want to replace it with the new one, they have to be setting this amount aside by year. So you can see that it's simple. So that is the solution to the question. We have come to the end of the question. If you have any question, let me know in the comment section, okay? And before you go, don't forget to like and share the video, okay? I'm not even asking you to subscribe now. I'm asking you to like and share the video. And if you want to be part of this channel, you can subscribe, but make sure you like the video and share the video, okay? So that will be all for this class. See you in the next class.